Hi guys, welcome to the next section of the course, Parallelize It. In this section, we'll look at the concept of concurrency and parallelism, as well as the differences between the two concepts. We'll also look at some of the main bottlenecks that constrain our concurrent systems. Now we move on to the first video of this section, that deals with concurrency and I/O bottlenecks. In this video, we will learn about concurrency and the major bottlenecks that impact our applications. So let's start with concurrency. Concurrency is, essentially, the practice of doing multiple things at the same time, but not, specifically, in parallel. It can help us to improve the perceived performance of our applications, and it can also improve the speed at which our applications run. The best way to think of how concurrency works is to imagine one person working on multiple tasks and quickly switching between these tasks. Imagine this one person working concurrently on a program and, at the same time, dealing with support requests. This person would focus primarily on the writing of their program and quickly context switch to fixing a bug or dealing with a support issue should there be one. Once they complete the support task, they could switch context again, back to writing their program really quickly. Now we will see the properties of concurrent systems. All concurrent systems share a similar set of properties. Let's see what they are. Multiple actors. This represents the different processes and threads all trying to actively make progress on their own tasks. We could have multiple processes that contain multiple threads, all trying to run at the same time. Shared resources. This feature represents the memory, disk, and other resources that the actors in the previous group must utilize in order to perform what they need to do. Rules. These are a strict set of rules that all concurrent systems must follow. These rules are vital in order for these concurrent systems to work, otherwise our programs would tear themselves apart. Moving further with I/O bottlenecks. I/O bottlenecks are bottlenecks where our computer spends more time waiting on various inputs and outputs than it does on processing the information. A great example of a program bound by I/O bottlenecks would be a web crawler. Now, the main purpose of a web crawler is to traverse the web and essentially index web pages so that they can be taken into consideration when Google runs its search ranking algorithm to decide the top 10 results for a given keyword. We'll start by creating a very simple program that just requests a page and records the time how long it takes to request said web page. Let's create a new document and name it as iobottleneck.py. Here we will add this block of code. On breaking down this code, first we import the two necessary modules, url_lib.request and the time module. We then record the starting time and request the web page, example.com, and then record the ending time and print out the time difference. Now, say we wanted to add a bit of complexity and follow any links to other pages so that we could index them in the future. We could use a library such as Beautiful Soup in order to make our lives a little easier. So, we will switch back to the directory to create another document and name it as iobottleneck1.py. Let's add a few lines of code and save this file. Navigate to the terminal and run the second file. Observing the result on the terminal, you'll notice that the time to fetch the page is over 50 seconds. Now imagine if we wanted to run our web crawler for 1 million different web pages. Our total execution time would be roughly 1 million times longer. The main cause for this enormous execution time would purely boil down to the I/O bottleneck we face in our program. We spend a massive amount of time waiting on our network requests, and a fraction of that time parsing our retrieved page for further links to crawl. In this video, we have learned about concurrency and I/O bottlenecks along with the example.